When a real security incident hits, many teams discover the hard way that saying, "we have backups," is not the same as "we can actually recover." Ransomware, bulk deletions, and cloud misconfigurations expose every weak assumption in your recovery story. This audio insight is part of my Tuesday Insights feature from Bare Metal Cyber magazine, developed by Bare Metal Cyber, and it focuses on backup and restore strategies that are built to survive those moments, not just look good on a status report. Backup and restore can sound like background plumbing, something that just runs in the dark while people focus on prevention, detection, and response. In practice, your backup and restore strategy decides whether an incident becomes a bad day or a multi-week outage. It is the safety net that lets you isolate systems, rebuild them, and get critical services back online with some confidence that the data is intact. Without that safety net, incident response becomes a desperate attempt to keep broken systems limping along because nobody trusts that a clean rollback is possible. At its core, a backup and restore strategy is a set of decisions about what you copy, where those copies live, and how you bring them back when the worst happens. It spans people, process, and technology. There are backup tools and storage platforms, of course, but there are also business owners deciding what is truly critical, operations teams scheduling and monitoring jobs, and security practitioners thinking about how an attacker might target backup infrastructure. When you zoom out, backup and restore belong to the entire organization, not just to one administrator or one team. It also helps to be clear about what backup and restore are not. They are not the same as high availability, which focuses on keeping systems running through redundancy, and they are not a shortcut around good design, monitoring, or access control. High availability can keep a system online while it is being corrupted or encrypted. Backup and restore are about capturing known good states and having a repeatable way to roll back to them. They are the last line of defense when both normal operations and preventive controls have been bypassed or have failed. Behind the scenes, most strategies follow a simple pattern: capture, store, verify, and recover. First, backups capture data and system states at specific points in time. Those copies are written to one or more storage locations, which might include local disks, network appliances, cloud backup services, or truly offline media. Then comes storage and retention, where you decide how long to keep different types of backups and how far back you might ever need to go to recover from corruption or a long-running compromise. Verification is where many organizations quietly stumble. It is not enough for backup jobs to report success once. Someone needs to pay attention to logs, error rates, the age of the most recent backup, and whether new systems are being picked up as the environment changes. The strongest strategies go further and include regular test restores. That can be as simple as restoring a small set of files into a lab environment, or as involved as performing a full system restore into a segregated network and checking that the application actually starts and can talk to its dependencies.
Recovery is where all of that preparation is put to the test. Imagine a ransomware attack that encrypts a file server and the virtual machines behind a critical internal application. Incident responders isolate affected machines, and the operations team looks for the last clean backups taken before the infection began to spread. They restore a database into a safe environment, run a few realistic queries to confirm that the data looks right, rebuild or restore the application servers, and only then reconnect users. The speed and confidence of that sequence depend entirely on earlier decisions about backup locations, access controls, and documented restoration steps.
You see the same pattern with less dramatic incidents. A user accidentally wipes out a project folder, or a configuration change breaks an internal site. When backup and restore are healthy, the help desk or operations team can quickly pull the needed files or roll a system back to a recent point in time. Those small, everyday recoveries quietly test the strategy and keep skills fresh. They also build trust because people see that restoring from backup is a normal part of operations, not an exceptional event reserved for disasters. Backups also play a role in change management. Before major upgrades or risky maintenance, teams can take fresh backups or snapshots and label them clearly. If the change goes badly, they do not have to reverse engineer every step. They can roll back to the known good state from just before the work started. Over time, this makes it easier to patch systems, refactor services, and experiment with improvements because there is a clear safety net behind each change, rather than a silent hope that nothing breaks. On the security front, backup and restore strategies are central to responding to targeted attacks and widespread malware. A practical starting move for many organizations is to pick one or two high-value systems and harden their backup posture first. That might mean storing copies in a separate security zone, using storage that keeps backups unchangeable for a period of time, and restricting who can delete or modify those copies. From there, teams can look at more complex services that span multiple systems and design recovery sequences that bring each part back in the right order. When backup and restore are working well, they deliver more than just the ability to roll back. They create a sense of resilience. During an incident, people can focus on containment and investigation because they know there is a path to recovery. Leadership conversations shift from pure fear of data loss to more concrete questions about which services will come back first and how long specific groups will be affected. Even outside of incidents, a credible recovery story helps with regulatory expectations, customer assurances, and discussions with insurers. Of course, these benefits come with trade-offs. Strong backup and restore strategies use storage, network bandwidth, and staff time. More frequent backups and faster restoration targets increase that cost. There is also complexity to manage. Multiple backup tiers, cloud and on-premise copies, and offline archives all need clear ownership and monitoring so that they do not become a tangle nobody fully understands. And there are cultural trade-offs. Agreeing that some systems recover in minutes while others take longer requires honest conversations about business priorities. The limits of backup and restore are just as important to recognize. They cannot compensate for an application that was never designed with recovery in mind, or for an identity system that has become a single fragile point of failure. They do not guarantee that every last transaction or message will be preserved, especially for systems that change rapidly between backups. If backup infrastructure is not protected, attackers can target it directly, encrypting or deleting the very copies you are counting on during an incident. Many failure modes show up as quiet red flags long before a crisis. Backups might be configured once and then left unattended, with nobody reviewing reports or asking how new systems are being added. Restores might be so rare that few people on the team remember the exact steps. Documentation might be outdated, or it might live in one person's notebook. In those environments, any serious incident will turn restoration into a stressful, improvised effort, even if the underlying tools are technically capable. Healthy signals look very different. There are regular, visible checks on backup health for critical systems, and someone can quickly answer questions about when the last good backup was taken. Small restores happen often enough that support and operations teams are comfortable performing them. Recovery steps for key services are written down in a way that people actually use, listing not just the main system, but also the dependent databases, configuration files, and integrations that must be brought back into alignment. At a higher level, you know your strategy is maturing when backup and restore are part of planning rather than an afterthought. New applications are introduced with clear expectations about what data they hold, how quickly that data needs to be recoverable, and where the backups will live. Security teams include backup infrastructure when they think about threats and hardening. Incident response plans describe concrete restoration actions instead of vague language about using backups if needed.
At its heart, a backup and restore strategy is about making sure that bad days stay survivable. It gives you a way to absorb mistakes, failures, and deliberate attacks by returning critical systems and data to a known good state. When you treat backup and restore as living practices rather than background utilities, they become a core part of how you manage risk and support the rest of your security work.
As you look at your own environment, the most useful questions are simple. Do you know which systems and data truly must be recoverable, how quickly they need to return, and from where you would restore them during an incident? And have you proven that story through real restores, not just green check marks in a console? If the answers feel uncertain, that uncertainty is not a failure. It is a guide to where you can take the next small step toward a recovery strategy that will still be standing when an incident arrives.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.